Hello and welcome you all to this deep Hive Mind session. This channel belongs to innovators who is in search of next generation innovations for future. Here we covers topics related to technology in IT fields. Our major goal is to share in-depth knowledge of that specific topic. Please feel free to drop questions on the topic or share your struggles and experiences in the comment section. We'll be happy to answer your questions in the end, or else the moderator will collect the most upvoted questions so we can answer them for you and pin them below in the comment. So without further ado, let me deep you into today's video. Today's video is on the Recurrent Neural Network. RNN is a type of artificial neural network. Let's have a look on what we will be taking away from this video. Firstly, we will learn what is RNN or Recurrent Neural Network. Secondly, we will look how RNN works. Then we will cover training of RNN. Fourthly, advantages and disadvantage in RNN. And lastly, we will see applications of Recurrent Neural Network. So, let's start with what is RNN? Recurrent Neural Network, RNN, is a type of neural network where the output from the previous step are fed as input to the current step. In traditional neural networks, all the inputs and outputs are independent of each other, but in cases like when it is required to predict the next word of a sentence, the previous words are required and hence there is a need to remember the previous words. Thus RNN came into existence, which solved this issue with the help of a hidden layer. The main and most important feature of RNN is hidden state, which remembers some information about a sequence. RNN have a memory which remembers all information about what has been calculated. It uses the same parameters for each input as it performs the same task on all the inputs or hidden layers to produce the output. This reduces the complexity of parameters, unlike other neural networks. Let's see how RNN works. The working of an RNN can be understood with the help of the below example. Example, suppose there is a deeper network with one input layer, 3 hidden layers, and 1 output layer. Then like other neural networks, each hidden layer will have its own set of weights and biases. Let's say, for hidden layer 1 the weights and biases are W1, B1, W2, B2, for the second hidden layer, and W3, B3, for the third hidden layer. This means that each of these layers is independent of the other, i.e. they do not memorize the previous outputs. Now the RNN will do the following. RNN converts the independent activations into dependent activations by providing the same weights and biases to all the layers, thus reducing the complexity of increasing parameters and memorizing each previous output by giving each output as input to the next hidden layer. Hence these 3 layers can be joined together such that the weights and bias of all the hidden layers are the same in a single recurrent layer. The formula for calculating current state, RNN where HT-current state, HT1-previous state, XT-input state. Formula for applying activation function, tan. RNN. RNN where WHH-weight at recurrent neuron, WXH-weight at input neuron. The formula for calculating output. RNN. YT-output. Y-weight at output layer. Now let us look into training through RNN. A single time step of the input is provided to the network. Then calculate its current state using a set of current input and the previous state. The current HT becomes HT1 for the next time step. One can go as many time steps according to the problem and join the information from all the previous states. Once all the time steps are completed, the final current state is used to calculate the output. The output is then compared to the actual output i.e. the target output, and the error is generated. The error is then backpropagated to the network to update the weights, and hence the network, RNN, is trained. Advantages of recurrent neural network. An RNN remembers each and every piece of information through time. It is useful in time series prediction only because of the feature to remember previous inputs as well. This is called long short-term memory. LSTM. Recurrent neural networks are even used with convolutional layers to extend the effective pixel neighborhood. Disadvantages of recurrent neural network: gradient vanishing and exploding problems. Training an RNN is a very difficult task. It cannot process very long sequences if using TAN or ReLU as an activation function. Let's have a look on applications of recurrent neural network. Language modeling and generating text. The language model is modeling the probability of generating natural language sentences or documents. You can use the language model to estimate how natural a sentence or a document is. Also, with the language model, you can generate new sentences or documents. Speech recognition. RNN seems to be more natural for speech recognition than MLP because it allows variability in input length. The motivation for applying recurrent neural network to this domain is to take advantage of their ability to process short-term spectral features but yet respond to long-term temporal events. A recurrent neural network speech recognition chip IIS projects. Machine translation. RNNs are designed to take sequences of text as inputs or return sequences of text as outputs, or both. They're called recurrent because the network's hidden layers have a loop in which the output and cell state from each time step become inputs at the next time step. This recurrence serves as a form of memory. One-to-one typical neural network, one-to-many to one TTT, many to many TT recurrent neural networks. Image recognition, face detection. An RNN is a type of neural network that can work with sequences such as text, sound, videos, finance data, and more. Combining CNNs and RNNs helps us work with images and sequences of words in this case. The goal, then, is to generate captions for a given image. 1C output layer input layer hidden layers recurrent neural network. Time series forecasting. Recurrent neural networks, RNNs, are deep learning models, typically used to solve problems with sequential input data such as time series. What are they, and how do we use them in time series forecasting? We will deep more into this in upcoming videos. Thank you for your presence, hope you like this informative video. See you in next video. Till then, keep learning, keep growing.